Hi all, welcome to Greenboard. So today we are going to discuss exercise 1.6. In the previous video we have already completed the previous exercise. So today we are going to discuss the final exercise of this chapter. So let's move on. So before going to the exercise questions, first we have to understand the equation, okay? And the equation is A union B. N of A union B equal to N of A plus N of B minus N of A intersection B. Okay, this is an equation and we have to study this equation by heart. Okay, we need this equation for doing almost every questions of this exercise. Okay, so we have to study this equation. N of A union B equal to N of A plus N of B minus N of A intersection B. Okay, and what does this N means? N means number of elements in a set. Okay, so here N is what? Here N of A. Okay, just a minute. N of A means number of elements in set A. Okay, similarly N of B means number of elements in set B. Okay, similarly N of A intersection B means number of elements. Okay, number of elements in both A and B. Otherwise number of elements in A intersection B. Okay, A intersection B. What does this A intersection B means? It means the elements are present in not only at A but also in B. It is present in both A and B because they will be the common elements of A and B. That does the term intersection means. Okay, so intersection can also be said as both A and B. Similarly N of A union B. Okay, it means number of elements in A union B or in other words A or B. Okay, either it should be present in A or it should be present in B. That is the meaning of the term A union B. Okay, so this is the equation and let's understand it with an example too. So let us understand this with an example. Okay, so here we are going to find N of A and N of B. Okay, so what does N of A means here? Here N of A means the number of elements that are present in A. Okay, so here our A is this circle. This is our A, isn't it? So how many elements are present here? There are 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 elements are present here. And what is our N of B? Our N of B will be this set is our N of B, isn't it? The whole circle B. Okay, so what are the elements that are present in N of B here? How many elements? 1, 2, 3, 4 and 5. Okay, so 5 elements are present in N of B and now we have to find N of A intersection B. Okay, next we are going to find N of A intersection B. Okay, so how many elements are present in both A and B? Okay, that is the next question which we have to discuss. So that is this petal shape region in the middle, isn't it? So it contains 2 elements, isn't it? So our N of A intersection B is 2. Okay, now we are going to find N of A union B. Okay, so look here. If A contains 8 elements and B contains 5 elements, how many elements will be there in total? That means in together A and B there will be 8 plus 5 elements, isn't it? So that is 13. Okay, so let us look whether there are 13 elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But there is only 11 elements. There is no 13 elements. So what happened here? While we counting, when we are counting, while counting A, okay, first we counted the elements in set A, isn't it? So we counted these much elements, and when we counted B, we counted these much elements. Okay, so while counting the B, we added this common region once again. Okay, it is already included in A, and when we count the B, we added it one more time. Okay, that's why there is an increase in 2 here. Okay, 2 elements are excess, that makes it 13. Okay, so we added the common elements again, that means 2 times. That happened here. Okay, so what we have to do, we have to subtract that common elements, that 2 from here, then we will get it as 11. Okay, so what we subtracted here, we subtracted intersection. Okay, so first we added A and B. Okay, so we added n of A plus n of B, and we subtracted the common region one time. Okay, then n of A intersection B, we subtracted it, and that makes our answer n of A union B. Okay, so n of A union B equal to n of A plus n of B minus n of A intersection B. That is the equation means. Okay, so we understood the equation. Now let's move on to the exercise questions. Okay, this is our question. What does it means? Here given that there are 2 sets x and y. Okay, there are 2 sets x and y, and here n of x equal to 17, n of y equal to 23, n of x union y equal to 38. Okay, so in the equation we have studied there exists 4 terms, and the value of 3 terms are given here, and we have to find the value of the 4th one. Okay, so when we got an equation, otherwise when we got a question, what we have to do, first we have to write the hypothesis. Okay, what does the term hypothesis means? We have to write the given data that are essential for solving these questions. Okay, so we need the value of n of x, isn't it? So n of x equal to 70, that we needed. So we can write n of x equal to 17. That is our first data. And what is our second one? Second, it is given that n of y equal to 23. That also we need that. So we can write n of y equal to 23. Okay. Then what does the next one means? Next we need n of x union y, because it is also given in this question. Okay. Here given n of x union y equal to 38. So we have to write n of x union y equal to 38. Okay, and we don't know the value of n of x intersection y, isn't it? So what we have to do, we have to write n of x intersection y equal to question mark. We don't know the value. Okay, so this is the first steps of writing the answer for an exam. Okay, so this much we have to write for an exam initially. Okay, now what we are going to do, we are going to solve the equation, isn't it? So we have to write the equation. What does our equation mean? n of x union y equal to n of x plus n of y minus n of x intersection y. Okay, otherwise n of A union B equal to n of A plus n of B minus n of A intersection B. This is our equation, but here it is given in terms of x and y. So we replaced A as x and B as y, and we write this equation. Okay, now we are going to substitute the values. Okay, so n of x equal to 17. So in place of n of x, what we can write? 17. Then there is a plus. Then n of y equal to 23. So in place of n of y, we can write 23. Then n of x union y equal to 38. So in place of n of x union y, what we can write? 38 equal to this value we don't know. So either we can write n of x intersection y, otherwise you can give a name like A, B, etc. Here I am giving n of x intersection y. N of x intersection y. Okay, so 38 equal to, we have to add this. So 7 plus 3 is 10, 0, then balance 1, 2 plus 1, 3 plus 1, 4, minus n of x intersection y. Okay, from here onwards there are two ways to solve. One I will show here and the other one the following. Okay, so 38, 38, this plus 40, we need the value of n of x intersection y, isn't it? So we need equal to n of x intersection y, otherwise we need what? N of x intersection y equal to one side should will be like this, isn't it? So here what we have, here we have minus n of x intersection y, so we will get minus n of x intersection y equal to, and the remaining terms from this side have to be replaced to the other side. So what is the remaining term here? There is a plus 40 excess here, so we are replacing it to the opposite side of equal to, so we are replacing it to this side. Then what will it become? Minus 40. Okay, so 40 minus 38 is 2, so minus 40 minus so 38 minus 40 is what? Minus 2 equal to minus n of x intersection y. If there are negative in both sides, we can cancel it. So what is our answer? 2 equal to n of x intersection y. Okay, in other words, how we can solve from here onwards? Okay, from this side how we can solve it? Here it is given that 38 equal to 40 minus n of x intersection y. So either we need equal to n of x intersection y, or we need n of x intersection y equal to. So here I am replacing this minus n of x intersection y to this side. So when it moves to the opposite side, the negative will become positive. So when we reach it, so when it reaches this side, it becomes n of x intersection y, it becomes positive. Here it was negative, in RHS it was negative, so when we replace it to LHS, it becomes positive. So what is remaining here? There exists a 40 here. So at this side we need only n of x intersection y, but what x is there in excess? There is a 38 here, so we are replacing it to this side, that means RHS, then it becomes minus 30. So n of x intersection y equal to 40 minus 38 2. Okay, in both way we got the answer as n of x intersection y equal to 2. So that is the answer. So look at our next question. Here it is given that if x and y are two sets such that x union y has 18 elements. So here given that x in union y has 18 elements. So how we can write in our hypothesis? Here n of x union y equal to 18. That means n of x union y equal to 18 elements means n of x union y equal to 18. So that is the first line of our answer. Okay, so what is our next line? X has 8 elements. So from that what we can write? Since x has 8 elements, we can write n of x equal to 8. Okay, then our next one. Okay, it is given that y has 15 elements, isn't it? Y has 15 elements. So what we can write? N of y equal to 15. That does the term y has 15 elements means. Okay, so given that how many elements does x intersection y have? How many elements does x intersection y have? So what does it means? We have to find the value of n of x intersection y. Okay, so n of x intersection y equal to question mark. Okay, this much is the hypothesis that we can write from the question. Okay, now we are going to solve it. So to solve, what we have to do? We have to write the equation first. So we know the equation. Either you can write with a and b, or you can write with x and y directly. Okay, so n of x union y equal to n of x plus n of y minus n of x intersection y. Okay, so we are going to substitute the value. So n of x union y equal to 18. So n of x union y equal to 18. In place of n of x union y, we write 18. Then what? N of x, isn't it? N of x is 8. So at n of x we can write 8, then here is a plus, then comes n of y. So in the place of n of y we can write 15, we can replace it with 15, then comes minus n of x intersection y. Okay, so this is the format of our equation. Then what we can do, 18 equal to 8 plus 15, isn't it 23 minus n of x intersection y. From here we can solve it in both manner, isn't it? So 18, this plus 23 is replacing to this side, then it becomes minus 23 equal to minus of x intersection y. Then 23 minus 18 is 5. So 18 minus 23 is minus 5 equal to minus of n of x intersection y. Since there are equal to in both sides, we can cancel it. So 5 equal to n of x intersection y. In the other way, how we can solve? 18 equal to 23 minus n of x intersection y, isn't it? So n of x intersection y is replacing to this side, then it becomes here minus, so here it is positive. N of x intersection y. Here there is 23, then this plus 23 is replacing to this side, then it becomes minus, plus 18 is replacing to this side, then it becomes 80 minus 18. So n of x intersection y equal to 5. Here we after equal to there are 23 and n of x intersection y. In first way we replace 23 to this side, and in the second way we transferred n of x intersection y to this side. Okay, in either way we will get the answer. So here the answer is 5. Okay, so let's move on to the next one. So look at our next question. This is a real life example. Okay, we can use, otherwise we can apply this equation in similar type real life problems. Okay, so what it is, in a group of 400 people. Okay, so given there are 400 people in total, and among them 250 can speak Hindi and 200 can speak English. We have to find how many people can speak both Hindi and English. Okay, so here H and E are coming, isn't it? For Hindi I am taking the set H, and for English I am taking the set E. So first we have to write it. Okay, here H. Okay, H means set of people speaking Hindi. Okay, that is our H here. And what does our E means? E equal to set of people speaking English. Okay, so we defined our two sets. It will be easy. We can solve it with the x and y, but it will become a bit confusing. So if we give the direct letters, it will be more easy for us to do. Okay, so it is given that there are 400 people in total. It has in total, grand total is 400. So what does it mean? N of H union E. Okay, n of H union E equal to 400, because there are 400 people in total there. Okay, then 250 can speak Hindi. It is given that 250 can speak Hindi. So n of H, our n of H will become 250. Okay, then it is also given that 200 people can speak English. So n of E, our n of V will be 200. And what is our question? Our question is how many people can speak both Hindi and English, isn't it? So when it comes the term both, otherwise when the word both comes, we know it means intersection. Okay, so n of H intersection E equal to question mark. We don't know its value. Okay, so up to this question we find that the value of union, isn't it? I think so. No, we solved in the same manner. Okay, so this is the same type question, but it is a real life manner problem, isn't it? So in a class of people, okay, there were 400 people in a class. Okay, 400 students are sitting in an auditorium, and one of the teacher came to the stage and asked how many people can speak Hindi. Okay, fluently. So 250 people from those auditorium students raised their hands. Okay, and then she asked how many people can speak English. Okay, so a 200 people can raised their 200 students from that auditorium raised their hands. Okay, so some students raised a hand in this both questions. Okay, some students can speak both Hindi and both English. So when they ask the Hindi knowing students, they raise their hand, as well as when they ask the English knowing students too, they raise their hands. Okay, so we have to find the number of students who raise their hands in both Hindi and English. That does the term N of H intersection E means here. Okay, so what we have to do, we have to write the equation first. So N of X intersection Y equal to N of X plus N of Y minus N of X intersection Y. This is our equation. Okay, sorry, N of X union Y. Okay, so what we have to do, we have to replace X with H and Y with E. If you guys are able to write it directly without writing this, you can do it. If you become a bit confused, you can first write this equation and then replace it. Okay, here I am replacing X with H. Okay, so here is an X, so I am writing H there, and here is an X, so I am writing H. Here is an X, so I am writing H. Okay, then what we have to do, Y, we have to replace Y with E. Okay, so wherever there is Y, we can write the E. Okay, so here is a Y, sorry, so we are replacing it with E, and here is also a Y, so I replaced it with E. So the equation for this question is N of H union E equal to N of H plus N of E minus N of H intersection E. So what does we do next? We have to replace it with the values, otherwise we have to substitute the values. Okay, so N of H union E equal to 400. So at this place we can write 400 equal to, then N of H, we know N of H is 250. So 250 plus, and comes N of E. N of E is 200 minus, we don't know this answer, so either we can write N of H intersection E, otherwise you can give letters like A, B and lot. Okay, here I am giving N of H intersection E itself. Okay, so 400 equal to, when adding this we will get 450 minus N of H intersection E. Okay, so from here onwards we can solve it in two manner. Either we can replace 450 to this side, so plus 450 will become minus 450 equal to minus of N of H intersection E. Okay, so minus of N of H intersection E equal to, when we subtract 400 from 450, it gives us 50. Here we are subtracting larger number from a smaller one, so there will be a negative. If there is negative in both sides, we can replace it, we can cut it, isn't it? So it will become 50 equal to N of H intersection E. Okay, or in other way, how we can solve it? 400 equal to 450 minus N of H intersection E. Okay, here we replace 450, so here we are going to replace minus N of H intersection E. We are going to transfer minus N of H intersection E to this side, so it will become positive. So 450 is here, then this plus 400 will come to this side as minus 400. Okay, so N of H intersection E equal to 50. In either way we got the answer as 50. So the 50 students in that auditorium raised hands for both the questions. Okay, so let's move on to the next one. One more thing we can do from the next question onwards, we can show the Venn diagram also. When it becomes an intersection, but it will be a bit difficult to you guys, so I am not doing it in this question. From the next question onwards we can do. When we do it in this one, I think you guys will become a bit confused, because to solve the Venn diagram of intersection, it is a little difficult, that's why. Either you guys can show it, the final answer you can solve by Venn diagram. Okay, here it is H and here it is E. Okay, so in total H have 250, so here you can write 250, and in total E has 200, and how many are in common? H intersection equal to 50 is common. Okay, so this is our equation. This is the Venn diagram of the same. Okay, so look at our next question. If S and T are two sets, okay, so here the name of our sets are S and T. Okay, so in S and T are two sets such that S has 21 elements. So given that our set S has 21 elements, so how we can write our first step? N of S equal to 21. Okay, and it is given that T has 32 elements. Okay, T has 32 elements. So what we can write from it? N of P equal to 32. Okay, and it is given that N of S intersection T equal to, otherwise S intersection T has 11 elements. So up to the last question we have to find the value of intersection, isn't it? We solved the intersection part. Okay, but here from this question onwards it is given the value of intersection. So N of S intersection T equal to 11 here, and we have to find how many elements does N of S union T have. So here in this question we have to find the value of N of S union T. Okay, that is not given in this question. Okay, so this is the hypothesis of our question, and here what we have to do? First we have to write the equation, isn't it? So N of X union Y equal to N of X plus N of Y minus N of X intersection Y. Okay, either you can write this equation by heart, otherwise you can replace it directly and write the one. Okay, so here N of S union T equal to N of S plus N of T minus N of S intersection T. Okay, so given the values, N of S union T is not given. Okay, so N of S union T equal to, N of S is 21, so N of S equal to 21 plus N of T. At N of T we can write 32, and minus at N of S intersection T we can write 11. Okay, so there are plus and minus, both are coming together, so we know the word BODMAS. Okay, so this is bracket and this is of division, multiplication, addition and subtraction. Okay, this maybe you guys are not familiar with this, so you are familiar, but at this time you don't know, and I am not explaining this. Okay, at this moment. And what does it mean? After addition we have to do subtraction. A and S is coming. Okay, in that order we have to do. So first we have to add. Okay, add these elements, then we have to subtract. Okay, so 1 plus 2 is 3 and 3 plus 2 5, so 53 in total minus 11. 5 minus 1 4, 3 minus 1 2. So N of S union T has 42 elements in total. Okay, in Venn diagram how we can do it? This is our union set and we need two overlapping circles S and T. Okay, so this will be our set and we have to name it. Okay, this is the universal set and S as well as T. Okay, so N of S has 21 elements, N of T has 32 elements, T has 32 and the common part has 11 elements. So this is our equation, or this is the model of our Venn diagram. And here what does our equation tell? First we have to add the both sets, so X and Y, otherwise S and T we have to add. So we have to add S elements first and then T elements. Okay, so how many elements does S have? We have did it separately, so it is easy. First we have to add the S part, so it has 21 elements, 21 plus then we have to add T part, isn't it? So we have to add this T part is this one, so we have to add it. So 32 we are going to add 32. Then what we have to do? Minus, we have to subtract. What we have to subtract? S intersection T, which is this common region. Okay, so we have to subtract S intersection T, this blue part we have to subtract. So minus 11. So when we add it we will get 53 minus 11 and the answer will become 42. Okay, it can be drawn in other way too. Sorry, Given that 11 is the total number of common elements, isn't it? We know that this full S contain 21 elements and 11 is common. So 21 minus 11, that is 10. So only S has 10 elements. Okay. Then what does the other part means? In total this T has 32 elements. 32 elements are in total in T, and from that 32, 11 is common. So how many elements is present only in T? That is 32 minus 11. Okay, that is 21. Okay, so when we add these all together, that means 10 plus 11 plus 21, we will get 42. Okay, in both way we can solve it. Okay. So that's all for today. Thank you for watching Greenboard. See you again. We can solve the other part of exercise in next one. Okay. Thank you. See you again.